and welcome to the January 2014 edition of Curriculum Connection. I'm Medford's Curriculum Director, Laura Lundy. There's a lot of excitement stemming from the new middle school's tech ed curriculum, the STEM Academy. Students are learning what it's like to be an engineer and have had the opportunity to build T-bots, trebuchets, and CO-powered eggsters. The STEM Academy curriculum is based on engineering principles. Middle and high school tech ed teacher Scott Geisler explains.
At this age level, STEM Academy teaches the kids, first of all, what an engineer is. It explains or explores different areas that engineers can work in, and teaches kids basically what kind of jobs they could have if they were engineers. The activities that we do are all, they're problem-based, and kids have to come up with some sort of a solution. So it makes kids use the engineering problem-solving process. It makes kids design and then test and then redesign and test and collect data. So I think it's a real good introduction to Project Lead the Way in high school.
One of those hands-on projects is the T-bot.
What I learned in tech ed is how to use STEM technology in other classes, and this specific item is the T-bot. And what we had to do is we got like a packet and we got little pieces, and every day we get a little bit out of the packet. So what you do is these syringes, we fill them with food, water and food coloring, and it's based on hydraulics. So when like you pull the syringe back, it moves the T-bot, and each one has this. But it's kind of a challenge to fill up the water and food coloring, because if you get air in the line, then it doesn't work very well. Like this yellow one, I think it kind of has a lot of air in the line, so it won't.
Although some of the projects have students building from a kit, others, like the Eggster project, have students both designing and building their own cars. And the students I talked to had lots of ideas.
He lets us go online and we look at these cars, and we want to make it as aerodynamic as we can, so the more aerodynamic, the more faster it'll go. So I kind of got my idea off the line, like a sports car.
What I was planning to do was take like a bag of air with straw going through to the egg with an empty bag, so when it smacks the wall, push the air over here. But then I was going to cut out the middle to make it, well, less mass, and to stick my straw in there, so it'd be a little easier than having to drill all the way in there. But I'm trying to make this more as aerodynamic as possible, so, and light as possible. And then after I kind of figured out my speed designs, I thought if I had enough time, I'd actually stick like a golf ball pattern or like alligator scales on there, because I read somewhere that alligator scales are the same as a golf ball pattern, because golf ball patterns are made to be aerodynamic and go farther.
Whether they are building from a kit or designing their own, kids say they are learning science and math principles.
The more potential energy we had, the farther the ball would end up going.
For example, like if the more weight you have on the end of this, the more potential energy you have.
The water pressure from one moving toward another can push the green one, it'll push it up, and if you pull it back, it'll retract all the water and fluid.
Students also practice their communication skills by writing their observations in their engineering notebook.
Every day we just write down what we did and like what we could have done better and what we fixed.
In addition to tech ed, this program offers ways to collaborate with other subjects, such as science and math. Due to scheduling, this is the most difficult challenge of implementing STEM Academy. However, this spring, Mr. Geisler will be attempting to partner with science teachers to complete a Sea Perch unit.
In the spring, to get together with the high interest science classes and build a sea perch. Well, sea perch is basically it's a sea device. It's a device that will float and you can navigate. It's used for science experiments in the ocean.
Although STEM Academy is a new addition, the curriculum did not completely replace everything old. Mr. Geisler says that some of the traditional tech ed projects still exist in 8th grade.
And it's kind of interesting in the sense that we've kept the core idea of tech ed, which is the hands-on, which is great. But I think now this movement that we have towards engineering is a very positive thing. And what I like about it is that so many of the kids realize now that they have the potential to do this. With that being said, though, it's also so important to keep what we have, the traditional type tech ed, because the two go together really well. You know, the kids in this class, in the STEM classes, they design everything and they come up with solutions, but being able to build it is the second piece of that puzzle.
Cool, and then the end result to see how it works. It's just kind of neat to see it move and just kind of see that you made this. Like, it's just kind of neat. So.
My favorite was probably just the final product and just playing around with it. And once after we put the food in it, we got to put it on X and Y coordinate, and we got to move and pick up objects.
According to a 2012 U.S. News and World Report article, students who graduate with an engineering degree have an excellent chance of being hired due to society's growing need to devise solutions to technically challenging problems, such as global warming, the shortage of clean water, and the demand for faster and smarter computing. Through the middle school's STEM Academy and the high school's Project Lead the Way courses, Medford is inspiring and preparing future engineers to solve these problems. For Curriculum Connection, I'm Laura Lundy.